Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in. Okay, let's do some Hooke's law questions. So a spring is stretched by hanging masses off the end of it. 200 grams are hung on the end of a 10 centimetre spring with a spring constant 500 newtons per metre. What is the final length of the spring? Okay, so first things first, we need our equation for Hooke's law, F equals kx. And what do we have in our question? We have our spring constant k is equal to 500. We don't know what our extension is. And the other thing that we've been given is the mass, which has been hung off the end of 200 grams or 0.2 kilograms, getting grams to kilograms by dividing by 1,000. So how can I use this information? Well, what we know, because these masses are being hung off the end, that the weight of those masses will be equal to the force F. So let's find that weight. So to find it, I do my mass times G. 0.2 times G, 10 gives me 2 newtons. And then let me put that into my equation. Force 2 equals K 500 times X. X equals 2 divided by 500, and that gives me 0.004. But that's my extension, and the question didn't ask me for that. It asked me for my final length. So how do I find my final length using my extension? Well, I want my initial length, which it did give me, which was 0.1 meters, 10 centimeters, plus that extension, 0.0, that should be 0.004, equals 0.104 meters. Okay, next question, what is the energy stored in the spring? So I need my other equation. Energy is a half times k, spring constant, times extension squared. So let me just plug everything in. Half times 500 times 0.004 squared gives me 0.4, and my unit is joules. Okay, what is the mass required to stretch the spring to 1 meter? Why might this not be true? So what are we doing here? We have our original spring with my spring constant 500 and an original length of 10 centimeters. And I want to stretch it to a meter. So what's my extension going to be here? Well, it's going to be 1 meter minus the 10 centimeters that it is at the minute, which is 0.9 meters. I need that extension to be. So what force am I going to need to stretch it 0.9 meters? Well, I'm going to need k times x, which is 500k times 0.9 is 450 newtons. Didn't ask me that, it asked me what the mass was. So if I have that force working backwards from last time, that must be equal to my weight, which is my mass times g, and therefore that force 450 equals the mass times g is 10. So if I divide that 450 by 10, I'll get my mass to be 45 kilograms. Why might that not be possible? Well, at that point, if I applied 45 kilograms, probably stretching this spring beyond its elastic limit. So remember, its elastic limit is where it no longer is going to return to its original shape, but actually it's going to undergo some plastic deformation or inelastic deformation, where once you would remove that mass, it doesn't return back to its original shape. But once it's gone past this limit, it no longer obeys this F equals kx Hooke's law. So I can't use this calculation to work it out. Okay, some questions using our energy equation. So if 50 joules of energy is stored in the previous spring, how much does it extend? Okay, so my E is 50, my K from the question before was 500, and I want to know my extension. So I've got my equation, E equals half K x squared. So that is 50, E equals half times K 500 times x squared. So simplifying, I've got 50 equals, well, half times 500 is 250 x squared. So divide 50 by 250, I get 0.2 as x squared. And then square rooting, I get 0.45 meters. Again, how much energy would be stored if the extension were doubled or if the spring constant were doubled? So I've got my equation E equals half kx squared. And since my extension is the one I'm going to do first is going to be doubled, but I've got this squared relationship, x squared. Actually, if I double that extension and make it 2x, I get this factor of 4x squared. So what I'm actually going to get is that 0.9 is going, which gives me an extension of 0.9 if I double it. So I've got energy is half times 500 times 0.9 squared is 200 joules. But hopefully you can see there that the amount of energy has quadrupled, and that's because of this x squared relationship of my extension. Now, what about my spring constant? Well, if I double my spring constant, I go from k to 2k, and so my k is 1,000 instead of 500. And if I calculate the energy, I get 100 joules by changing that spring constant. So by doubling the spring constant, you double the amount of energy stored in your spring. Okay, and using a graph here, what is the energy stored in the spring when the extension is 3 millimeters? So I've drawn on some things there. So at 3 millimeters, I've got a force of 19 newtons. And it's helpful to know that my energy stored is going to be the area under this graph. So how am I going to figure out that area? Well, I've got the area of that triangle there. And so that is just 3 millimeters times 19 divided by 2 for my area. Make sure though I've got those millimeters into meters before working it out. So 3 times 10 to the minus 3, or 0.003 times 19 divided by 2 gives me my final answer there in joules. Okay, now to do some questions with my pressure equation. So first question on the left here is, what is the pressure exerted by an object with an area of 5 meters squared and a force of 80 kilonewtons? So let me write my variables out. My force, now this is 80,000, not 80, because in order to get my pressure into pascals, I need my force to be in newtons, not kilonewtons. So to convert between those two, I multiply that 80 by 1,000, 80,000 newtons. My area is in meters squared. That's the unit I want it to be in, so I keep it as 5. Now I need my equation. Pressure is equal to force divided by area. So the pressure is 80,000 divided by 5 is 16,000 pascals. Next question, what is the force of an object exerting a pressure of 100 kilopascals over an area of 0.03 meters squared? So my pressure, again, it's been quoted in kilopascals, but I need it in pascals. So multiply that 100 by 1,000 and get 100,000 pascals. And my area is 0.03. My equation is pressure is equal to force divided by area. And I'm looking for my force here, so I need to rearrange that equation. And I get force is equal to pressure multiplied by area. So 100,000 by pressure in pascals times 0.03, my area in meters squared gives me 3,000 newtons. What is the area in contact with the floor of an object exerting a pressure of 5 pascals with a mass of 60 kilograms? So my pressure is 5, and I'm looking for the area, but I haven't been given a force. However, I have been given a different piece of information. I've been given the mass as 60 kilograms. Now, the force that this object is exerting on the floor is its weight. So what I need to do is remember, how do I take my mass and get it into the weight? And I have that equation from previous topics. Weight is equal to mass times g. So my weight is 60, the mass, times g is 10, is 600 newtons. Now I have got my force 600 and my pressure 5. My area, I need to rearrange that equation. It's going to be my force divided by my pressure will give me my area. 600 divided by 5 is 120 meters squared. Okay, let's do another example. So what is the largest pressure in pascals
exerted on the surface by a cuboid with measurements 6 meters by 7 meters by 10 meters, and it has a mass of 400 grams. So again, I'm using this equation, pressure is equal to force divided by area. And what I need to appreciate is, depending on which orientation I have this cuboid, I will exert different pressures on my surface. Now, why is that? Well, if we think about it, the mass is the same no matter which way up my cuboid is. So the force, the weight that is being exerted on the floor is the same. But what I can change is the area that is in contact with the floor. I can give it a larger or a smaller area depending on which side of my cuboid I place onto the floor. So to get the largest pressure, I need the smallest area, because if you look back at my equation, getting a really, really small area means dividing by something very, very small. So that will be a larger pressure if I divide by something smaller. So I look at my shape again, and I've got three options. I can put the side that is 7 by 10, the side 7 by 6, or the side 10 by 6 down onto my floor. And the one that will give me the smallest area is the one with the smallest length. So that will be the 7 by 6 side that I'm placing onto my floor. So the area is 6 times 7 is 42 meters squared. And in order to find my force, just like in previous example, I need to find the weight that's being exerted. So weight is the mass times G. Now, I've got my mass actually in grams here, 400 grams. And my weight in that equation needs to be in kilograms. So first, I need to take that 400, divide it by 1,000 to give me my mass of 0.4, times G is 10, that is 4 newtons. Pressure then is force divided by area, 4 divided by 42, 0.095 pascals. Okay, what is the pressure of the object above in Newton per centimetre squared? So, when you work out something in pascals, the equivalent unit is Newton per metre squared. If you think about it, dividing the force Newton by your area in metres squared. So here what it's asking me to do is find the pressure again, but this time Newton per centimetre squared. So I might notice that actually the force is still in newtons. That's still exactly the same. So the force that I'm going to be using is still that 4 newtons. But my area is going to be different, because this time my area needs to be in centimetres squared. And I think it's easiest to do this going back to the length and making sure those lengths are in centimetres before I multiply them together. So 6 times 10 to the 2, or 600, okay, 600 centimetres in 6 metres, times 7 times 10 to the 2 gives me 420,000 centimetres squared. So then my pressure, I do 4 divided by 420,000, and that gives me 9.52 times 10 to the minus 6 Newton per centimetres squared.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Some tips and tricks for this section. So axis units on energy stored. So any of those graphs where you have force and you have extension, before you calculate the energy being stored in your spring, for example, make sure to convert, if you've got kilonewtons on your y-axis, into newtons first, okay? And again, your extension could be quoted maybe in millimeters, and you would need it in meters before you started to plug it into the equation or to work out your area under the graph. Units in your equation, okay, your force equation, force is kx, meters, newtons, and Newton per meter for your spring constant. So it's a great one for them to get you to do conversions. Same for your units in your pressure equation as well, okay? Kilonewtons probably needs to be in newtons. And if you want your pressure in pascals, your area is going to need to be in meters squared. Okay, write stuff out. What I mean by write stuff out is write your equations out properly, write your variables out properly. The amount of times I see pupils miss out the squared, for example, on energy is half kx squared. And if you just write it out and then very careful to write square next to whatever number your extension is, you're less likely to get that wrong. Force can be a weight of masses. So this is both in pressure and also in your spring. If you're adding masses to your spring, you might need to use that to calculate the force using your equation for weight. And remember, in that equation, the mass is in kilograms.